Thanks, Simon. Merrick, welcome.
Thank you. How good was lunch? Amazing. Who's ready for a nap? Cool. We're going to talk about security compliance. I gave Chris too many notes for my introduction, but as I said, I've come to talk to you from Python New Zealand. I'm involved in organizing Kiwi PyCon, which is our national Python conference. By day, I do DevOps and cloud engineering and information security in the payments industry. And in my spare time, I do speed flying and paragliding. So I spend a lot of time thinking about risk and risk management, which is really interesting. So question, why is working on personal projects so much easier and more fun than coding in our day jobs? This is a question for you guys. Shout out, what makes personal projects more fun to you? Right. So they're limited in scope, no tech debt, no consequences. We have very high autonomy to get things done our own way. And within or just on the edge of our comfort zone. I want to suggest a few of my own, or formalize those into a few ideas. So one of the things that make it really easy to work on personal projects is simplicity and locality. We don't have to get stuck waiting for other people. We can really just put our headphones on and do our own thing. It's easy to get into a flow state. So again, because we're not handing off to other teams and we can really just do our own thing, we can really get into a flow state easily and just go for it. And the other thing is psychological safety. As someone shouted out, there's no consequences. We can try, we can fail. No one's going to deride us for our mistakes. It's a really safe place to learn. Work, on the other hand, can be a chaotic place. And Conway's law basically describes how organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. And you have many teams, and they need to communicate, and they have different priorities and requirements, and you need to try and develop software in this chaotic ecosystem. And the last few decades of software development wisdom have been trying to find a way to help organizations find ways to work more effectively together and have more autonomy. So there's a few books I'm going to present through this talk. The book will be on the left, and I highly recommend going and reading it if you haven't. But the first ideas I want to present are the 5 ideals presented in the Unicorn project. And they present these ideas of DevOps through locality and simplicity, focus, flow, and joy, improvement of daily work, psychological safety. I'm just going to dive into a couple of them. Locality and simplicity. We need simplicity in everything we do. The last place we want complexity is in our daily work, especially avoiding unnecessary complexity. Focus, flow, and joy, per the title of this talk. How does our daily work feel? Is our work marked by boredom and waiting for other people to get things done on our behalf? Is our work handed off from dev to QA to security and back to dev again? Do we blindly work in narrow silos, only seeking the outcomes of our work during infrequent deployments? Or do we work in small batches, deploy often, and get fast and continual feedback for our work? DevOps is not tools. It's a set of ideals and principles that drive technical practices to deliver software delivery performance, stability, quality, and value. And the key ways we do this is from eliminating hardships in the value stream. That's partially done work, motion, which is largely handoffs, and waiting for other teams. Task switching, so if you've handed off your tasks to another team, to QA, it might take them a couple of days to get back to you, and you need to pick up other work in the meantime. Non-standard or manual work, so things that aren't automated or everyone has a different idea of how to do them, things that aren't scripted. And you get very variable outcomes from these processes. And then extra processes, so anything that's like sort of unnecessary, having to get manager sign-offs for things, it really breaks our flow. So in the DevOps handbook, these are described as hardships in the value stream. And they break our flow of being able to continuously write code, test, release, deploy. The name of the game becomes eliminating the hardships and speed running of this cycle as fast as we can without breaking everything in the process. And so there's a lot of research out there, the DORA State of DevOps report, that tries to collate stats of how other teams, or how teams in the industry perform from following some of these ideals. And you can see there's a really big difference between low and elite. And I'm just going to zoom in on medium and elite. And it's a difference for change lead times between 1 and 4 weeks versus less than 1 day. High-performing teams can deploy on demand. They have incidents and errors less often, and when they do, they can recover from them extremely quickly. And when you scale this up to larger and larger teams and organizations, they can deliver software and deployments a lot faster. And this was taken to the extreme. In 2009, Mark Zuckerberg coined the motto, move fast and break things. And the entire industry said, no. Banking, healthcare, aviation, and government organizations. But I'm sorry, these slides are out of date. Because these industries have basically consequences for breaking things. We have personally identifiable information and incredibly sensible information like payment data and patient healthcare data, things that would literally ruin lives if they were breached and made public. And we've seen plenty of examples of those over the years. So those standards are there to protect the integrity, availability, and privacy of our data. And that's, like I said, personally identifiable information, payment card information, and protected health information. And they do those, so we're going to zoom in on just PCI DSS because that's the one I'm most familiar with working on. And it's also particularly prescriptive and restrictive. So here's some example things that really break our flow and cause a lot of friction in my previous team trying to deploy our payment software fast and at scale. So requirement 632 said that code changes have to be reviewed by individuals other than the originating code author. Hopefully all of us do peer reviews, so that's not completely unreasonable. But it is an example of a handoff. And depending on how you do that process, it can either be a breeze or really painful. 632 said code review results must be reviewed and approved by management. And this is probably one of the ones that caused us the most pain. And I want to talk about how we improved that process. And 6.4 said a separation of duties between personnel assigned to the development test environments and those assigned to the production environments. It's kind of vague, and there's a little bit more information in the standard. But this one is especially a roadblock for a lot of teams and organizations because it can be interpreted in a lot of ways. And I want to have a look at the troubles that caused. So all of these enforce hardships, extra process, motion, task switching, and waiting as we have to hand off to other devs and QA teams and management for our sign-offs. And it really destroys our locality and simplicity because we have to go out to other teams, and it really destroys our flow because we're stuck waiting for our sign-offs. So, although there's a lot of regulation about how things are secured in prod and how they get to prod, provided that we're not accessing prod systems or data, or modifying any segmentation between prod and non-prod data and systems, we can really do whatever we want and whatever we need up until the point that we're touching prod. So before we even worry ourselves about sign-offs and reviews, there's a lot of things we can get right just in our dev and test processes. The first one is really basic, and hopefully we're already all on top of this, but it's high test automation. We want to make sure that all of our testing is as automated as possible, and the manual tests are really just largely exploratory. We should have a good base of automated unit tests and a lot of good end-to-end tests to make sure that we're not we're not breaking our software and our users' expectations. So this, you can express it as the software testing ice cream of sadness, or anti-pattern, and the ideal software testing pyramid. So hopefully in 2025, we all know that test automation is good, but you'd be surprised, it's pretty basic. The next thing that our team really focused on was self-service, on-demand, pre-prod, and dev environments. And the key things for these is, it's all in the title. They need to be self-service. Anyone should be able to spin up an environment whenever they need. They shouldn't have to raise a ticket with another team or ask a colleague. It should be ideally a one-click flow. And they should be fast and automatic to spin up and down. They shouldn't take hours and hours. You, at worst, should be able to start the process, go up, get a cup of coffee, come back, and your environment should be up and running. So the Accelerate book expresses two architectural patterns that basically define or predict really well which teams achieve good software delivery performance. And teams that agree with these statements that we can do most of our testing without requiring an integrated environment, and we can do deploys or release our application independently of other applications and services it depends on. Those teams that agree with those statements generally tend to be on the higher end of the performance groups. Requirement 6.3.2 said that code reviews and results are reviewed and approved by management prior to release. But in Accelerate, from the research that they found over multiple years, they found that external approvals are negatively correlated with lead time, deployment frequency, and restore time. Approval by an external body, such as a manager or a change approval board, simply doesn't work to increase the stability of production systems. It's sort of security theater without actually delivering meaningful improvements. That's not to say that we don't want oversight and we don't need oversight, but the research found and recommends that we should use a lightweight change approval process based on peer review, such as pair programming or an intra-team code review, combined with a deployment pipeline, read automation, to detect and reject bad changes. Computers perform repetitive tasks, people solve problems. We actually double down on automation and make it as quick and easy as possible to test and review our code. Sorry. So where a very basic CI pipeline might enforce some coding standards, pip 8, and run your unit tests and run your integration tests, we can actually go a lot further than this to speed up the process of getting our management approval and sign-off. A really basic thing to add is a test coverage check to make sure that your unit tests are actually covering a reasonable amount of code. You might turn on a test coverage check and find that you're actually only testing maybe 30 or 40% of your code. You should set targets and try to improve this, but the first thing is measuring. So that's a really quick and easy one. The first one I want to talk about is secret detection scanning. I have another talk where I go into much more detail about this, but the idea is that we want to make sure that no password certs, keys, or like any sort of sensitive authentication data are committed into version control. And there's a couple of tools you can look at. GitLeaks is free and open source. GitGuardian is a commercial product. And you can throw these into a pipeline really easily. So now we've got a pipeline that's making sure that we're not leaking our keys into public or even private repos. Another thing you can add that's pretty easy to drop in is dependency vulnerability scanning. There's a third-party tool called pip audit, which you can install from PyPI, which will tell you if any of your dependencies have known vulnerabilities. I think pip audit is going to become built into pip in the near future, but I'm not sure what the timeline on that is. But it's very, very easy to install into a pipeline. So this helps us meet one of our PCI DSS compliance, which requires us to maintain an inventory of bespoke and custom third-party software components incorporated into, sorry. The requirement is to keep an inventory and stay on top of any vulnerabilities in the software in the inventory. And so by having our dependencies in a requirements.txt file or a pyproject.toml, that is already a form of inventory of our software. And by running these automation tools across it, it helps us know if any of them are insecure or need changing. And you can run this on every single commit and push to your repo and force it to block before merging. So we've got secrets detection scanning in our pipeline now. We've got dependency vulnerability checks in our pipeline now. I want to quickly touch on static analysis security testing, which you can think of as a linter for application security issues. And so there's a couple of tools you can look at, SimGrip and Bandit. I've done talks on Bandit, but they will scan your code and look for possible security misconfigurations. You might have developers putting a SQL injection in there, unsafe YAML, Ginger template injection. It looks for hundreds of different security mistakes that you can make in your code. And if you put that in your pipeline, then you can cause, you can block merges of any code that's introduced in one of these security issues. So we've already got quite a few more extra checks in that pipeline. This one is extra for experts, but dynamic analysis security testing. So whereas static analysis looks at the code itself, dynamic analysis needs a running instance of your application and will dynamically try to test and find for specific kinds of vulnerabilities. If we have our pipeline that has all of these steps in it, then it's pretty much shipping time. Hopefully we're passing all of those all the time now. But again, requirement 6.4 says a separation of duties between personnel assigned to the development and test environments and prod. And like I said, this one is open for interpretation, and a lot of people read this as your devs cannot deploy to prod. Accelerate, again, has a suggestion for this. They suggest that there's basically two mechanisms which can effectively be used to satisfy the letter and spirit of this control. So all reviews should be conducted by a peer who is not involved in authoring the change. So that is just the independent code review. And it should be recorded in a system of record. And that's pretty broad. But in practice, what that means is that a system of record is your version control system. If you're using Git or GitLab, that has a full record of everything that's been merged, and you can implement an approval workflow there that requires 1 or 2 approvals before you merge. So either by approving a pull request or running a manual stage in the CI/CD pipeline, you now have a full record of everything that's been done. The second suggestion is that changes should only be applied to production using a fully automated process that forms part of a deployment pipeline. So instead of having an operations engineer going and FTPing things to the server, hopefully now we're largely using GitOps and automated CI pipelines to do the deployment for us. And in this way, we're replacing the segregation between a developer and an operations person with a developer and an automated process. And so by doing this, the deployment pipeline gives our auditors a complete record of who authored the change, what they changed, when they changed it, where the changes were applied, and how the changes were validated. This process can be useful for all kinds of changes, including code, infrastructure, and database changes. So we use that for everything from application code, our infrastructure as code. We use it for database changes and patches, and pretty much any other cloud action we'd want to automate. You can put it in a script, put it in version control, and work through that process. PCI says nothing about once we have approval, PCI doesn't say, oh, you just have to throw that out into prod. We can definitely still follow modern production engineering principles. So we can do canary or dog food deployments where we put it out and we only serve the new version of the application to a few of our customers. And we can increasingly roll that out to 5, 10, 20%, all the way up to 100% of our customers. We can use feature flags. We just need to make sure that people who are able to turn on and turn off feature flags, there is an audit record of who did it and why, but the scope for introducing backdoors or that is very limited. We just need to know what's enabled and what's not enabled. And of course, we can do modern observability. The standards do not preclude us from doing any of these things. So again, I want to say DevOps is not tools. It's ideas and principles. It's technical practices that drive the stability and quality. And so we need to remember the principles, and we need to let them guide our technical practices. And they do require a bit of thinking and careful consideration for how we take those and make them fit into our security compliance frameworks. But it's definitely possible. There's nothing about any of the stuff that is incompatible with also following some basic security standards. So that is my talk. Thank you very much. And here's links and resources to everything that we've discussed.